All right, incline plane. Let the good times roll. So again, this is in the history of ratios document. All the details about joules and work and things like that. So just to give it a little bit of explanation here. So if you've ever lifted a box, and again, this kind of scenario, you have the box on the ground. It's sort of heavy. It takes a little bit to get in the air. But as you rotate it, it sort of gets, in a sense, it feels lighter. So you have to put a lot of effort in, but once it gets up, it gets lighter and lighter, and then until you get it to this point. So here we start with a low center of gravity, and we get to a little bit of a higher center of gravity with this scenario. So just to talk a little bit about joules and work, and we'll get into that, but if we go kilograms to Newton, we got 10 kilograms, 8 meters, if we're going to move this 8 meters. So we end up with 98 newtons. And if we deal with joules of work equals newtons times meters. So 98 newtons times 8 meters equals 784 joules or newton meters. So if we got 98 newtons here. So if we got 10 kilograms and it's free falling at 9.8 meters per second squared, 9.8 meters per second, it's just going to free fall at that rate. So if we just look at this here, at 0 degrees, we have the mass is 10 kilograms times 9.8 meters per second squared. Gives us 98 newtons. The acceleration is 0. We're dealing with, I just have a circle put up here, up to whatever degree in here. So if it's just sitting flat, as this would be, we can move it sideways. We have to put some force in, but there's really no acceleration other than the energy we put in. If it's free falling, then it's just sitting perpendicular to the surface, straight down. So we use the sine angle here, and the sine of 0 degrees is 0. So it just shows that there's no acceleration here. If we go to 90 degrees, the mass, so the sine of 90 degrees is 1. So 10 kilograms gives us 98 newtons. The acceleration, 9.8 meters per second squared, times the sine of 90 gives us 9.8 meters per second squared. Now we have, at 45 degrees, we have the mass, 98 newtons. But the acceleration now is changing. The sine of 45, and the acceleration now is 6.9 meters per second squared. And the funny thing about this is, if we just take this into the equation, 10 kilograms times the acceleration, just as we would do here, because it gives us 69 newtons. Now if you look online, you'll see sometimes people that weigh themselves on an angle, and they weigh less. So that's kind of a funny little thing about that. So what we have here is at 45 degrees, the acceleration is 0.707 to 1. 30 degrees, the acceleration would be 0.5 to 1. Now this is the sine of angle theta, and this is the sine of 90 degrees. So right here, at a 45 degree angle, 9.8 meters, also, if this was just 1 unit, 9.8 meters also equals 1 second. Now the hypotenuse here, relative to 9.8 meters, would be 13.8 meters, and relative to 1 would be 1.414, just straight geometry. So what we want to do here is get everything into their vectors. So if we're just sitting flat to the surface, we have our x-axis and our y-axis. Now if we're sitting on an inclined plane, we want to get it, the x and y now are on the same angle as the plane. We have our natural force, and in this direction the force of acceleration. But what we want to notice here is right here, this becomes the hypotenuse, which is the force of gravity, because the force of gravity is still pulling straight down. So, and what we have now is the separation between the force of gravity and the actual angle that the load is sitting at. Our acceleration is going to be relative to the opposite, which, if we just draw a parallelogram here, the opposite becomes, this becomes your F net, your net force, or your force of acceleration. So what we have here is there's less acceleration because over this amount of time, if we just look at it as far as distance is concerned, and 9.8 meters equals 1 second, well, it's taking longer down this plane here, down the angle, to reach this point, as opposed to just it free falling straight down. So it's really a ratio here of the angle to the actual just straight free fall. So if we look at what this means, so if we have an inclined plane with no friction, the force F equals ma. So this is Newton's laws here, again in the history of ratios. The F is equal to force, Fg, force due to gravity, Fn, the normal force, acts perpendicular to the surface. So if this is the surface, the Fn is perpendicular to it. Fa is the force of acceleration, which is the F net. M is mass, and A is acceleration. So if we have a mass of 10 kilograms on an incline of 30 degrees, what is the acceleration? And that's what we're going to be calculating for here. So the force of gravity, Fg, right here, force of gravity, which is the mass times the gravitational force. So Fg, which is equal to the hypotenuse, as I was talking about right here. This is the hypotenuse. This is the opposite, which is mass times gravity. So we're just going to do a conversion here into newtons. 10 kilograms times 9.8 meters per second squared gives us 98 newtons. The force of acceleration, which is the opposite, equals Fg times the sine of 30 degrees, gives us 49 newtons. So the acceleration which is this scenario right here, because it's affecting the newtons are being affected. They're together there. So the acceleration is F net over m, gives us 49 newtons to 10 kilograms. So it's telling us that it's accelerating at a rate of 4.9 meters per second squared. So if we just change, so take the same weight, we'll just change the incline here a little bit. Instinctively, notice the 30, so we have less degrees. So you may instinctively just realize that it will accelerate at a lesser rate. So if we take the same equation here, Fg equals the hypotenuse, yada yada, so 98 newtons, that hasn't changed any. And we're going to multiply that by the 20 degree angle, and gives us 33.5 newtons. So that means that we are accelerating at a rate of 3.3 meters per second squared. And if we just carry on down the line, so we've got 30, 20, 10, just to just to bring the numbers out with the math. Keep it simple. The same kilograms worth of weight. And we do the same thing. 98 newtons, 10 is 17. Plug that into the formula. Gives us 1.7 meters per second squared. Now what's interesting about this is that when we take 10 kilograms, 10 degrees, acceleration, 90 newtons, 17, 1.7 meters per second squared. But we change the mass to 20 kilograms, 10 degrees, same deal, just a different weight. We find we have 196 newtons here, times the angle, this is 34, but the acceleration isn't changing any. Now again, remember, this is no friction. So the masses, they cancel out. They become irrelevant. And it's the angle that's affecting the rate of acceleration within this formula here. So that's one thing to just be aware of when it comes into this scenario with inclined planes. So if we just progress here and we add friction, we use the symbol, this U here, otherwise known as mu, Greek letter. We'll use the same formula, but we're going to apply mu. So here, there's nothing changing. So we got Fg, do our conversion to 98 newtons, Fa, F net over m. So now what's changing here is the friction is affecting the rate of acceleration by the cosine. So we have mass times gravity, mg sine 45, minus mg times the cos of 45 times mu. So the mu is what's affecting us here. So, but we have introduced the cos now. So mg factors in to both. So we can change this here. So mg, and again, it's F net over m. So we have mg times the sine, of 45 degrees over m. And here's the note, the masses cancel out, m and m. So then we end up with g times the sine of 45 minus the cos of 45 times mu, when the g is 9.8 meters per second squared, minus these values, reduce it a little more, so we end up with 5.5 meters per second squared. If we change it up here, and we go to 20 degrees, we'll find, similar to the calculation with no friction, that we will have a lesser rate, but again, affected by the u, and that is calculated in all sorts of, everything's going to have a different friction. So rubber or grass or anything like that. So this is left up to the scientists here. So we got 98 newtons, and we just plug that all into the formula. I've reduced this formula here. This is just to show you the process. This is simplified. And we end up with, so we're still at 20 degrees here. So we got sine 20, cos 20 times mu. Plug all the numbers in, and we end up with 1.5 meters per second squared. Now, this is simply a concept, sort of a thought experiment, but we have a friction force here, which is opposing the force of acceleration. So, as far as the geometric shape, if we take the same magnitude, apply it up here, but we reduce it by mu, we have an accelerated force heading in this direction, and then a slight reduction of force that's holding it back but not stopping it. If you apply mu enough, you'll find through the calculation that there will be no acceleration. There's too much friction force. So this is just a little thought experiment here. But that's about it for inclined plane.